In the hours before dawn on December 19th, 2025, while most people across North America are still asleep, something very special will be happening at a certain point in the sky. A comet, not just any comet, a visitor that doesn't belong to our solar system, a cosmic messenger that has traveled for billions of years through the intergalactic void, will reach its closest distance to Earth. A wounded object almost disintegrated, yet still able to continue its journey into the unknown. Its name is 3I Atlas, and it's only the third interstellar object ever observed in human history. Stay with us if you enjoy being amazed. Just a moment, guys. Only 13% of subscribers know when we publish new videos. Make sure you subscribe and turn on the notification bell, because without it, you'll miss formats and documentaries you won't find anywhere else. Right now, as you're listening to these words, 3I Atlas, its name indicating it's the third interstellar object identified in our neck of the woods, sits about 270 million kilometers or 168 million miles from us, almost twice the distance separating us from the Sun. And it's crossing the constellation Leo at a dizzying speed of over 240,000 kilometers per hour or 150,000 miles per hour. No, you won't see it with the naked eye or even with binoculars. But if you have an amateur telescope with at least 20 centimeters or 8 inches of aperture and a dark sky far from city lights, then you'll be able to catch a faint luminous halo, a blurred patch at magnitude 10, 11 that barely stands out from the background stars. You'll have to get up very early, about 2 hours before dawn, when the constellation Leo will be high above the eastern horizon. Look for Regulus, its brightest star. Well, 3I Atlas will not be far from there. Sure, it's little more than a fuzzy dot, a small nebulosity that doesn't resemble the spectacular comets with bright tails that occasionally cross our skies, yet it represents something far more profound and significant. That faint patch of light is material that formed around another star, in a planetary system hundreds or even thousands of light years away, at a time when perhaps our own sun hadn't even been born yet. It's a fragment from another world, a message in a bottle thrown across the cosmic ocean that has randomly reached our shore. Astronomers are buzzing with excitement. From the Gemini Observatory in Hawaii to the Hubble Space Telescope to the Atlas Telescope network that discovered it, to NASA's probes around Mars and beyond, an armada of instruments is pointing towards this visitor. The observations on December 19th will be crucial because this is the moment of closest approach. After this date, 3I Atlas will continue its race, moving farther and farther away, becoming progressively fainter until it dissolves into the darkness of deep space. In March 2026, it will pass near Jupiter, then it will definitively leave the solar system, never to return. Never before in human history have we had the technological tools to study in detail an object coming from another solar system. When 1I Oumuamua was discovered in 2017, the first confirmed interstellar visitor, we had already almost lost sight of it before we realized what it was. It was moving away too quickly and observations were few and fragmentary, leaving us with more questions than answers. 2 years later, in 2019, came 2I Borisov, an interstellar comet that gave us more time to study it, but that one too vanished quickly. Now we have 3I Atlas, and this time we're prepared. We've managed to intercept it when it was still far away, in July 2025, thanks to the Atlas surveillance system in Chile, one of the robotic telescopes that continuously scan the sky, searching for dangerous asteroids. At that moment, 3I Atlas was a tiny speck at magnitude 17, 6 times fainter than Pluto, visible only with large professional telescopes, located beyond Jupiter's orbit at about 670 million kilometers or 416 million miles from the Sun. But its trajectory immediately appeared anomalous. The calculated orbital eccentricity turned out to be 6.1394, an extraordinarily high value, the highest ever measured for any celestial object. For comparison, 1I Oumuamua had an eccentricity of 1.20 and 2I Borisov of 3.36. An eccentricity greater than 1 means a hyperbolic orbit, not gravitationally bound to the Sun. And this, in simpler terms, means that 3I Atlas isn't simply orbiting around our star, but is passing through the solar system following a very open hyperbola, practically a straight line. After the discovery, calculations then showed that the object had entered our solar system at a speed of almost 58 kilometers per second, or 36 miles per second, a value that exceeds the sun's escape velocity and certifies its external origin. When you trace its trajectory backward, it clearly emerges that it comes from the direction of the constellation Sagittarius, toward the center of the Milky Way. More refined dynamical analysis suggests it probably originates from the galactic thick disk, a population of old stars that orbit above and below the main galactic plane. This is fascinating because it means 3I Atlas could be incredibly ancient. Statistical studies on the ages of stars in that region of the galaxy suggest the comet could be between 7 and 14 billion years old. 3I Atlas could therefore be older than the Sun itself, a galactic fossil preserving within it the chemistry of a remote epoch in the universe's history, when the Milky Way was still young and turbulent, long before the Sun and Earth formed. When the comet was initially spotted, it appeared as an inert object, similar to an asteroid. But subsequent observations on July 2, 2025 by astronomers David Jewett and Jane Liu using the Nordic Optical Telescope revealed it was clearly active with a diffuse tail. Other telescopes confirmed the presence of cometary activity, with a tail at least 25,000 kilometers or 15,500 miles long. Spectroscopic observations from the Gemini Telescope and the Infrared Telescope facility on July 5th and 14th revealed that the comet's comma contained ice and silicate grains with a radius of 10 micrometers, confirming its nature as a true comet. At the end of August, the James Webb Space Telescope observed the comet detecting the presence of carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice being released as the comet warmed up approaching the Sun. These molecules tells us the story of an object formed in a cold and distant environment, probably in the outer region of a planetary system around another star, where temperatures were low enough to allow these volatile ices to condense and accumulate. Something, perhaps gravitational interaction with a giant planet, or perhaps a close encounter with another star, expelled it from its native system, launching it into interstellar space. Since then, it has wandered for eons through the galaxy, a solitary relic witnessing distant worlds. On October 29, 2025, 3I Atlas reached perihelion, the closest point to the Sun in its trajectory, at a distance of 1.36 astronomical units, about 203 million kilometers or 126 million miles, just inside the orbit of Mars. At that moment, Earth and the comet were on opposite sides relative to the Sun, so the object was invisible from Earth, hidden in the solar glare. But the orbiters around Mars were able to observe it up close. The Mars Reconnaissance Orbiter, with its ultra-high-resolution HiRISE camera, captured spectacular images of the comet when it passed only 30 million kilometers or 19 million miles from the red planet on October 3rd. The images show a comma about 1,500 kilometers or 930 miles in diameter, and ultraviolet data from the MAVEN probe revealed details about the gas surrounding the comet, including hydrogen associated with water. Even the Perseverance rover on the Martian surface briefly interrupted its exploration of Jezero crater to photograph the comet with its mast cam, while the Hubble Space Telescope observed 3I Atlas on July 21st and again on August 20th and at the end of November. Hubble's images allowed estimation of the cometary's nucleus dimensions, whose diameter is probably between 440 meters and 5.6 kilometers, 1,440 feet to 3.5 miles, and also its rotation period, estimated at about 16 hours. Hubble also revealed an interesting feature. The comma has a teardrop shape with an extension toward the Sun. According to analyses by Professor Avi Loeb of Harvard, this extension could be due to larger fragments that broke off from the nucleus during the perihelion passage and now precede the main body by about 60,000 kilometers or 37,000 miles. So is the nucleus disintegrating? It would seem so, and everything began when 3I Atlas's brightness started oscillating with an unusual rhythm. First, a sudden drop of 20% in less than 5 hours, then an unexpected jump upward due to the sudden release of gases trapped in the nucleus's pores. The telescopes recorded an expansion of the Comet in real time, like a labored breathing, a cloud expanding by thousands of kilometers, while tiny blocks of material, some a few meters wide, others perhaps tens of meters, broke away from the main body. In many high-resolution images, the nucleus no longer appeared as a single point, but as a set of inhomogeneous zones with differences in brightness and density that betrayed the presence of deep cracks, fissures opening up, areas where material was yielding to the expulsion of volatiles. It was at that moment that scientists understood this was no longer the usual cometary activity, not just plumes of dust flung away by solar radiation, but the beginning of a process of total disintegration. From Earth, the Gemini observatories and VLT recorded jets of carbon dioxide opening like fans in increasingly variable directions, a sign that the comet was rotating faster or irregularly, perhaps because part of its body had acted as a natural jet engine, expelling gas in an unbalanced way. Some dynamical models indicate that just a rotation of a few hours was enough to accentuate the fracture, because any tiny variations in angular momentum, even of 0.1 or 0.2%, are sufficient to stress a porous structure already weakened by sublimation. At that point, 3I Atlas was no longer a compact nucleus, but a body beginning to split along lines of weakness inherited from a remote and mysterious past. All of this is teaching us a great deal about the nature of interstellar objects. One of the fundamental questions is, how common are they? For a long time, we thought interstellar space was essentially empty, with stars separated by distances so vast that encounters between objects from different systems should be extremely rare events. The discovery of 3 interstellar objects in less than 8 years instead suggests that the space between stars is full of debris expelled from forming planetary systems. Simulations indicate that during the chaotic initial phases of a planetary system's formation, when giant planets migrate and interact gravitationally, enormous amounts of material are expelled into interstellar space. For every stable planetary system we see today, there should be millions or billions of smaller objects scattered throughout the galaxy. 3I Atlas, with its apparently fragile structure and tendency to fragment, supports the idea that many interstellar comets are porous and weakly bound aggregates, rubble piles held together more by gravity and ice cohesion than by any real structural solidity. This has profound implications for understanding how planetary systems form elsewhere in the galaxy. Every interstellar comet we manage to study is a direct sample of material from another system, a window into planetary formation processes that could be very different from those that generated our solar system. The chemical composition detected in 3I Atlas, with its abundances of carbon dioxide, carbon monoxide, and water, closely resembles that of comets in our solar system, suggesting that the fundamental processes of ice condensation in the outer regions of protoplanetary disks might be universal. But there are also subtle differences that astronomers are still analyzing. The reddish color of the dust in the comet revealed by the first observations is similar to that of 2I Borisov and indicates the presence of complex organic compounds produced by prolonged exposure to cosmic radiation. These organic compounds are fundamental building blocks for prebiotic chemistry. If objects like 3I Atlas regularly bombarded young planetary systems, they could play an important role in seeding planets with organic molecules. It's an interstellar version of panspermia, the idea that life or its chemical precursors can be transported from one world to another through space. Of course, 3I Atlas doesn't carry life forms, but it certainly carries interesting chemistry. However, the density of 3I Atlas is already written. After its closest approach to Earth on December 19th, it will continue moving away, becoming progressively fainter. In March 2026, it will pass about 54 million kilometers or 34 million miles from Jupiter, receiving an additional gravitational boost that will slightly modify its trajectory. Then it will inexorably continue outward at a speed of 200,000 kilometers per hour, or 125,000 miles per hour, cross Neptune's orbit, the Kuiper belt, and finally, definitively leave the Sun's sphere of gravitational influence. In the decades and centuries that follow, as it moves ever farther away, its cometary activity will cease completely. The ice in the nucleus, no longer heated by the Sun, will stop sublimating. The comma and tail will vanish. 3I Atlas will return to being what it was before entering our system: an inert, frozen fragment floating silently throughout the interstellar void. Over the course of millions of years, it will perhaps encounter other stars, cross other regions of the galaxy. It could one day arrive in another planetary system, where other observers, if they exist, might see it as we're seeing it now, and wonder where it comes from and what it represents. But for us, for humanity at this moment in history, 3I Atlas represents a window into a cosmos much larger and more interconnected than we imagined. It reminds us that our solar system isn't an isolated island in space, but is part of a dynamic galactic ecosystem where material, information, perhaps even life, travels from one system to another through the eons. Every time we observe an object like 3I Atlas, we're looking directly at tangible proof of this cosmic connection. So, if you can, in the hours before dawn on December 19th, or in the days immediately following, try to get up early, go outside under a dark sky with your telescope, point toward Leo, and search for that faint patch of light moving slowly among the stars. There's not much to see, it's true, but when you find it, stop for a moment to reflect on what you're looking at. Okay guys, so what do you think? Did watching this video raise any doubts or questions? Let us know in the comments. And if you want to learn more, check out the other videos we've dedicated to the interstellar comets on the end screen.